calculator, which I'm going to show you how to use right now. And we'll break class a couple minutes early so I can share it with you guys. I'll show it to you right now. Let's make sure we can see that okay. You don't have this on your machines yet. I will give it to you, like I said, as soon as we break for class, I'll share it with you. And I'm actually going to give you like 5 or 6 different programs. Some of you take a 244, I've written some custom ones for you too. So here's how it works. And I'll show you how to use this next time. I'll give it to you today and show you how to use it next time. You don't have it yet. It's called dist fill. Now let me show you how it works. The first thing it asks for is, what is the smallest value of X you'd like to analyze? So you have to start by knowing, okay, if I have 4 birds in my flock, what's the least number of girls I can have? Well, you know it's 0. You already figured that out. So 0. And what's the largest number of girls you can have? 4. Boom. You press enter. It now, if you stop the program right now, it has 0, 1, 2, 3, and 4 in L1. Just like you guys did right here. So it's put this in L1 for you automatically. It's about to fill this for you too automatically. But you have to tell it, what are we doing it with? Binomial is your first choice. I want to talk more about why this is particularly a binomial experiment next time. We're almost out of time. I don't want to get into that right now to rush through it. What's the probability we've been using all day long?
0.9.
0.9 is the chance of a chick. Oh, excuse me, the chance of a female chick. Yes? You put that in, you press enter, it says done. Now that's kind of, you're like, okay, it's done. What does it mean done? If you now press stat edit, do these numbers look familiar? There they are, right there. So, Natasha, it'll take care of all those multipliers for you. And the reason is, there is a formula for the binomial distribution. I've learned in the past 20 years, memorizing the formula is the worst way of teaching the binomial, because then people lose track of what they're actually getting. What I want you to do is look at that distribution and be able to say, holy crap, in roughly 95% of cases, I'm going to get no more than 1 rooster. Roughly 95% of the time, 65 plus 30, that's 95% of the time, right? I get no more than 1 rooster. That's the kind of crap that makes the binomial useful. Not the little formulas that generate the coefficients, although they're beautiful, and that's why I'll have a quiz for you for next week if you want to get into there and mess around with that. This is more important, because then you can run 1-bar stats, right? Then you can just go stat, calc, 1-bar stats on the list, just like you've always done. And there's your 3.6 average, just like we had earlier. You might was like, I don't like this at all. I'll make it fun, I promise. Because this is exactly what Gallup does, and exactly what CNN does, and exactly what every poll that you read. Congress is now less popular than syphilis. How do they know that? Because they're using the binomial distribution, and a good sense of humor. And a good sense of humor. If you want, I'm also going to give you a program that allows you to draw your distribution. That's what it would look like. There's the chance of 0 girls, 1 girl, 2 girls, 3 girls, and 4 girls. Gives you a nice skewed distribution look. Yeah, and you can almost envision that if you try to make a histogram out of this. It's going to be wickedly skewed, isn't it? Yes, wickedly skewed. Because it's skewed to one side. Yes. This is a better answer. Now I can get Danielle's flock. Huh? Ready? Oop, not that one. Let's do Danielle's flock. You had 18 birds, yes? So the smallest number of girls is 0, the largest is 18. Let it think for a couple seconds. Make it binomial, 0.9. It's going to take a little bit longer for it to fill it in, not much longer. Here is Danielle's distribution. Okay, there's the chance of having absolutely no girls. Essentially, it's not going to happen. Essentially, none of these are going to happen. You had 15 girls and 3 boys, right? Check it out. 15 girls and 3 boys. 17% of the time, you're going to get 15. That's not very rare. That's why I said I wasn't surprised. That's not very rare to get half and half. It's still on the rarer side than, say, 16 and 4, or 16 and 2. Excuse me, 16 and 2. But it's not like this rare up here. It's not like this rare up here. You see what I'm getting at? That's why I wasn't overly surprised when you said what you said. Fair enough? Now in that, to answer Natasha's question again, within that, if you think about it, there are 15 girls and 3 boys. So there's a 0.9 to the 15th power, and there's a 0.1 to the 3rd power in that calculation. Then the question is, what do you multiply it by to keep track? You need 18 pictures of birds if you pointing to them like this, right? The quick and easy answer, if you need it, is in the project. It's called 15, choose 3. No, 18, excuse me. 18, choose 3. 18 birds total. 18, choose 3. And you'll see what that means in your project if you haven't already seen it. But my point, and Natasha, was a great question, is don't get hung up on that calculation. This does it for you automatically in the code of the program. I'd rather you look at this and be able to look at that and go, oops, look, no longer is all girls the most likely outcome. Now you're most likely to have 1 boy and 17 girls, and you're not far behind with 2 and 16. And this is, again, not too far behind. If you run that draw program, that's what your distribution looks like. It's starting to pull into a bell curve. And you will see that more and more the more chickens you buy. Oh! It's all good though. It has to eventually. You can't beat the probabilities. It has to go back down. You can't.
I'll get lucky this time.
You might get lucky. What does the chart say? You might. It's 15%. I mean, that's a chance of all. Oh, you got 41. Shit. Oh boy. Hang on. You're gonna have 41, yeah? Oh God. 0.9. Gotta think a couple seconds. Okay. There you go. I don't know about luck. I think your luck's gonna run out. That's the chance they're all girls. That's essentially the chance that they're all boys. You're gonna get some. Every 10 birds should be a boy, right? Every 10 birds, you should have 1 boy and 9 girls. If you buy 41, there's almost no chance you're gonna have none of them. What is that? What is that one actually? They do. Roosters make pretty good soup, I've heard. Don't name them. That's the mistake we made. You got about a 1% chance of getting all girls.
Ooh.
I'm not trying to ruin your day. I'm just trying to let you know that your day looks like this. There's your bell curve. Thank you for bringing the bell curve for us. We'll head there next time too. Let's queue up. Does anybody know how to share programs on a TI?
No.
Okay, I'll do it real quick then. Make a little line. Let's get you these programs so you have them all. 89s, I have them on the computer. I can't share them on the 84. I have to give you guys special code. All right. We'll show you how to use it next time because we're out of time. Could somebody just close the screen on that camera? That'd be awesome. Thank you. Thank you.